Well, hello again and welcome back. This is a little extra bonus part to the energy unit. So if you're not supposed to be doing the bonus stuff, you probably shouldn't be watching this video. Go back to your tracking page and figure out where you're supposed to be. But for those of you that have moved on past quiz 2, I'm assuming that the calculations of KE and GPE well during the first part of the unit. So I'm going to show you how we can make some of those problems a little bit more challenging and a little bit more what I call advanced. So let me remind you first of the two formulas that I'm referring to. So kinetic energy, we call that energy of motion sometimes, is calculated 1/2 mv squared. And this stands for 1/2 times the mass of the object in kilograms times the speed of the object in meters per second. The other energy calculation we did was gravitational potential energy, GPE. That's the kind of energy that something has when it sits up high, above the ground or above a table usually. And it's calculated by multiplying the mass in kilograms times the strength of gravity wherever you happen to be. Typically we're on the surface of the Earth, where gravity pulls with 9.8 newtons on every kilogram. And then times the height in meters. So there's two things that I'm going to do to make these problems a little bit more advanced. Number one, instead of giving you M and V and having you find the kinetic energy, I could do a problem where I tell you how much energy you have, and then you figure out either the mass or the velocity. Show you a little extra math step that we do in those kinds of problems. Similarly, over here, I could give you the GPE, and you could calculate either M or G or H, as long as you have the other two. The other thing is we could do some unit conversions. And we did this as part of one of the labs in the unit. But there are times when the measurement that you have, let's say for height or for mass, is not in the correct units. You need meters for height, kilograms for mass, and for speed you need meters per second. Well, sometimes we measure heights in centimeters. Sometimes we measure masses in grams if we're using a balance. So you'll need to know these two conversions. 100 centimeters is equivalent to 1 meter. And 1,000 grams is equivalent to 1 kilogram. Now, it's important that you write these down because here's how it really helps you. You can look at this first one here and realize that when you have a number in centimeters, its number should be 100 times as much as the number that's with the meters. And similarly with grams and kilograms. If you have a grams number, it should be 1,000 times bigger than the accompanying or corresponding kilograms number. Okay, so if you keep those in front of you, you'll be able to remember which number should be bigger and how many times bigger. And then you just do a little calculation on your calculator. Okay, so let me show you an example of what I'll call an advanced energy problem. So, and we'll do two problems today. Example number one. An object is sitting 300 centimeters high and has 294 joules of GPE. Now, can you guess what I'm going to ask? Look at the only thing missing from this. Oh, I'm sorry. I threw an extra S on there. An object is sitting 300 centimeters high and has 294 joules of GPE. The only remaining number to be found is its mass. Okay, so we'll come back to those unit conversions in just a second because we're going to need that. I have described before that you use 3 steps when you're doing these math problems. You write the formula, you plug the numbers from the problem into the formula, and then you solve with your calculator. I'm going to insert an extra step between steps 1 and 2 for these kinds of problems. Okay, and let me show you what it looks like. See if we can focus here a little bit better. There we go. So step 1 is to still write the formula. All right, so we're dealing with GPE, so we use this formula here. By the way, I saw somebody wrote like step 1, step 2, step 3. You don't need to write the step number out. Just do each step, okay? If it helps you to put little dots in between, you can. That's just a reminder that you're multiplying. But you should have learned in math class that if you don't write any operation between 2 letters, you are implying that you're doing multiplication, right? Okay, so here's step 1. That's just as normal. Now, step 2 is to rearrange the equation using algebra skills that you should have by now. Rearrange the equation to solve for the missing letter. Okay? In math class, I believe in algebra, they call this solving a literal equation. Literal. You don't need to know that, but this should be something that you've done before. So, in this case, we're asked to find the mass. So what I want to end up with is, instead of GPE equals, I want M equals. All right? Now, a lot of students are more comfortable doing this if they actually put the numbers in first. But the better way to do it, the preferred way to do it, is to first do the algebra with the letters and then put the numbers in. Okay? So, notice here that 3 values are multiplied together and the product is equal to the GPE. So if you are missing any one of these 3, then dividing by the other 2, dividing GPE by the other 2 will give you the third. So let me show you what this looks like when we write it on paper. So we're solving for M. So you see where I'm pointing here. M right now is being multiplied by G and by H. So if we want to move those away from M, we do its opposite, its inverse, we call it in math. And the opposite of doing multiplication is to do division. So we're going to divide both sides by G and by H. So what does this look like? Well, on the right side, we're just left with the M, which is perfect. That's what we want. On the other side, the GPE gets divided by G and by H. Divided by G and H. Again, you can still have the little dot in between there if you'd like. So this equation that I've just written here is really totally equivalent to the one above it, but it's in a form that's better for this problem because we were asked to find the mass in kilograms. And so all we got to do is plug in these 3 numbers, which we were given in the problem, and we can solve. Okay? So there is the new step 2. Okay. Now, the remaining 2 steps that we've used in the past are now steps 3 and 4. All right. Plug in the numbers from the problem. So we plug in on top here the GPE number, which is 294 joules. And on the bottom, we have the product in G of G and H. Now, G is still the same, 9.8 newtons per kilogram, as long as we're on the surface of the Earth, which 99% of the time you will be. So 9.8 newtons per kilogram. And then the height, now here's where we've got to think about unit conversions. I must have the units all similar. I cannot have centimeters thrown in with meters and newtons and kilograms. Everything's got to be in consistent units. So this is where we use this equivalent unit conversion. Okay, so what you could do is you could go up here to the problem, actually maybe just over here in the corner somewhere, 300 centimeters. Now again, this is why I showed you this. A number in centimeters should be 100 times bigger than its equivalent number in meters. So if we just divide by 100, we will get the equivalent number in meters. So 300 centimeters is equivalent to 3 meters. In my classroom, I have meter sticks that we use. Each one is 100 centimeters. That helps you remember. So if you have 3 sticks, that's 300 centimeters. That's also 3 meters long. Okay. So we are going to use this number when we do this calculation here so that all the units are consistent. Okay. All right. Now we're going to grab a calculator and we'll do the rest on the calculator. Now I'll show you with my calculator how to avoid a mistake. Move this over here. People often make calculator mistakes when you're dividing by 2 different values. Now there's different ways to do this to avoid that. One option, I'm not going to use this option, is to just multiply the denominator first and get that product, 3 times 9.8, and then rewrite it, 294 divided by that number. But there's another way that we can do this, and it works out a little bit quicker. So we hit 294, and then each number we're dividing by, we just hit the divide by key. So we hit divide by 9.8, and then we hit divided by again. So that's really what we're doing. We're dividing by 9.8, and we're also dividing by 3. Okay? Then you hit enter, and you get 10. You see the answer there. And 10 what? Well, we're solving for a mass. And this, as long as the units are consistent in here, this mass should be the mass in kilograms. I like to box my answer. That way I know I'm done. Everybody else knows I'm done. Okay? So again, you could, let me just show you that alternative. You could multiply the 9.8 times the 3 first, and that gives you 29.4. And then you could say 294 divided by 29.4, and of course that's still going to give you 10. So you get the same answer either way on the calculator. Whatever you feel more comfortable doing is fine. All right? So you see the difference there between this and our kind of old standard problems. Number 1, we did have to use a unit conversion to make sure that everything was in meters, kilograms, newtons, joules. And also we had to do a little rearranging in step 2 to solve for what was asked for in our problem, which in my case was the mass. All right? So let's do a kinetic energy problem now. Probably one of the tougher ones where we're going to be finding the speed of an object. Okay, so here's our second example problem. You can pause this as you maybe write the problem down so you have it in your notes. How fast must a 25 kilogram mass move in order to have 800 joules of kinetic energy? Okay, so look what's being asked for here. We're asking for how fast. That's the speed. That's the V symbol in our equation. And we're given the mass, and we're given the kinetic energy. All right? So again, we're simply going to add an extra step in the problem-solving process. So we'll go from 3 steps to 4. This extra step will be right after step 1. All right? Step 1 is still to write the equation for kinetic energy. That should be written at the top of your page, or maybe it's committed to memory already. Okay. Now, in this case, we're solving for the value that's being asked for in the problem, which is, we use the symbol V for speed, remember? So there's a couple of algebra steps here. And you can use, as many as you're comfortable with, but don't try to do it too quickly, all right? So again, I mentioned this is probably the hardest one because of where this V is. So the goal is to kind of extract that out of the equation, if you will, all right? So I'm going to do this in several steps, all right? And I always like my steps to flow vertically, so I'll go straight down the page, and each step will be one little algebra move different from the one before, okay? So watch how I do this here. So again, what we're looking for is to have something that says V equals, all right? I won't do it right away, but I'll get there eventually. So the first step is to multiply both sides by 2, because what that does is it gets rid of the 1/2. Now in math class, they might suggest you do things like put a little indication here of what you're doing to both sides. I don't want to mess with what your math teacher has taught you in terms of proper form. As long as it's obvious to me how you're getting to the next step, I'm good with it. So we're going to basically multiply both sides by 2. So we get 2 KE equals, and then what happens here, the reason we're multiplying by 2 is the 2 and the 1/2 will cancel each other out. Sometimes I remember being taught to just cross those things out lightly, and then we're left with mv squared. Okay, so we doubled both sides and got rid of that little fraction, 1/2. All right, now we again have this understood multiplication, and so to leave v by itself, we're going to have to move the m to the other side, and the way you move m when it's being multiplied is to divide it. So I'm going to divide both sides by m. Again, in your math class, maybe they teach you to do something like this to show that you're dividing by m. You don't have to do that, again, if you haven't been taught that way. But what we get when we divide both sides by m is we get the 2ke over m. See, we write it as a fraction now. And what happens over here is that m divides out by this m, and we're left with just v squared. So I'm slowly working my way to getting v all by itself. All right, one last step here. This is v squared. I want just v. All right, so the way you get rid of a square is you do its inverse. And the inverse, or the opposite operation, is a square root. All right, now, also in this step, only because I like it in this form, I like to have the symbol that I'm solving for to be on the left side. Right now it's on the right side of the equation. It doesn't change anything, but I just like it better that way. So I'm going to flip-flop left for right, okay? So I'm going to bring the v over here, and I'm going to take the square root, so that's why I'm not writing the square. And then the square root of this side over here on the left, which I'm going to move over to the right. I'm not changing anything else. So here's what we get. That's our new, I call that the working formula because it works for the problem that we have here. It is totally equivalent to the very first one we had up here, the definition of KE, but it has been solved algebraically for V. All right? So I want you to be comfortable doing that process, not just watching me do it, or not just copying me do it, but get used to the steps, the algebra steps to solve for the missing letter, if you will, in these problems. But the good thing is that additional step 2 is now done, and now we can move on to the last 2 steps where we plug in the numbers and we use the calculator to solve for our missing number. So don't change anything about what you're writing here. We still have 2 times. Now the KE number should be given in the problem, and here it is, 800 joules of KE divided by our mass in kilograms was 25. Okay. And now again, just be a little careful on the calculator. I'll show you on my, this is a fairly simple calculator. If you're using one of my ones in the classroom, just do it in a series of steps, okay? Actually, the one in my classroom isn't going to work for these. So you're going to have to do something that'll have a square root key on it, all right? So if we start with what's under the square root, I'm going to do the square root last. Think about your order of operations. You got to do multiplication and division first. So it's 2 times 800 and divided by 25. Now, I'm rigging the numbers to be real nice in this case. So my last step is to square root this number. On my calculator, I have a square root. It's actually an inverse or a second function. Okay, and we see the number 8 there. And I would hope that you would know that the square root of 64 should be 8. And what units go with this? Remember, we're finding how fast it must move. How fast is a speed? And all of our speeds are in meters per second when we do kinetic energy problems. So that's that. Now, it might be a safe thing, especially if you're doing some math where you're a little bit uncomfortable, to go through and do a check. I'm sure your math teachers have taught you this too. Just take your answer, go back to the original problem, and plug it into the tried and true kinetic energy equation and just make sure it works. So 1/2 mv squared should still equal your kinetic energy of 800. Okay? So 1/2, which is 0.5, times m, 25, times 8 squared. Okay, you see what it looks like on my display. And then hit enter. 800. 800 joules does check out with what we knew. Okay, so you're sort of working backwards just to be sure that you didn't make an algebra mistake or a punching something wrong in the calculator mistake, because those are real common things. All right. Okay, so there we see it. A couple additional things to think about. How to do some algebra on your equation to solve for your missing letter, and if necessary, how to do some conversions on your heights or on your masses, depending on which one you have, so that you've got all the units consistent and you can solve for the right thing. All right, I'm going to turn you loose to do some practice on your own. Good luck.